Good afternoon, everybody. Today, we will going to talk about problem number 3 of IOI 2021 POCs. So the problem is like this. In a POC, you have M foundations, and then they are connected by horizontal or vertical line with a segment length of 2. I actually read this problem, this statement many times, and realized that the length can only be 2. It cannot be 2, 4, 6, 8, whatever. It's only 2. Then between the lines, you want to build a bunch of fountains that is like in between, either on the left-hand side or the right-hand side of the road. So the question is, can you build those fountains or you cannot? So here is one of the example, right? You have fountains at here, 4, 4, and left POCs at 4, 4, then POCs here. Then you have a road like this. So you want to build the fountain which is in the middle of the road, either on the left or on the right-hand side. In this case, you can build it. Basically, the fountain is on the anti-clockwise side of the road. Then there are going to be other cases that you cannot build it. So, for example, if I have like this, okay. So if it's like this, okay, and then you have more going on like here. So if you think about this one, you can only build on the left-hand side or on the right-hand side. Let's say you're building on the left-hand side, and then this one, let's say this one you're also building on the left-hand side for this. I just build the left-hand side for this. Then for this road, you have nowhere to build. Okay, then you are not doable. So how do you do this problem? This is actually a standard, traditional black and white ball. Sometimes people call it red and black ball problem. Is basically how do you color the thing, right? So the typical concept is if you color it by, let's say this is my white ball, and this is my black ball, and this is my white ball, and this is my black ball. Okay, you color it by different colors, quote unquote colors. So then in this case, it's easy to color, easy to decide the color, right? So for example, if my x plus y, right, is 2 times even, let me call it a y ball. Or if it's 2 times odd, and I'll call it a black ball, right? Remember, x and y, if you look at it, x and y are both on the even, right? So then you can color it. Once you color it, then you can say, if I go then on one side of if then I say from if I'm a white ball, I'm going to, if I start from a white ball, and let me draw it here. If I start from a white ball, I will assign my park fountain this way. If I start from a black ball, I will assign my fountain this way. So anti-clockwise for white ball and clockwise for black ball. Then you pretty much will not have conflict. If you cannot do it, then and if you cannot do it, then you say, "Oh, I'm not able to do so." Okay. So that's how you construct the road. Okay. Okay. So now let's go a little bit details on how do we do this. You basically, so what you do is you read a bunch of them, right? You read a bunch of them, reading all those balls. Then you first, right? The first step is you need to figure out the connection, right? Connection, which is our ADJ list, right? So you can, for example, you can first find out the y direction, right? So if you sort all the balls by x, right, then you sort it by y. Then if two of them have distance of 2, then there is a connection, right? Then you sort it by y first, right? Then any of them have left or right, that's your connection, right? So you first build your adjacent list, right? That's the first step. Then you check, then you check if there is connections, meaning, and if some of the balls, like some of the parks are, more than distance of 2 away, right? Then you cannot do it, right? So you do a fluff fill. You do a fluff fill, basically. That is a BFS, right? BFS or DFS, doesn't matter. You do a fluff fill, and you see whether you can reach all the parks or not. If you cannot reach all the parks, then you cannot build the fountains. Then the third step is you from 0 to a -1, right? A -1. For each ball, you identify it's white or black, right? It's white or black. Then you look at two directions. Okay, let's say we look at the right-hand side and look at up. Let's say we only look at these two directions, right? Because this, this is the right-hand side of this, right? And this is up of another, right? So you don't need to look at all 4, just look at 2 of them. So if you look at the right-hand side, okay, if I look at the right-hand side, okay, so if I'm a white ball, I want to put my park here, right? So then what would be the case that I cannot put park here is if I have, let's say, if I have from here, right, this is my thingy, and this is my right-hand side, okay. If I have a connection here, I know the connection is a black ball, right? Because this is a white ball, so this has to be a black ball. And this is a black ball, right? And this has to be a white ball, right? So if that, then if there is one here, as I said, the black ball, I'm going to put foundation here, right? So that is one of the case I cannot be, okay? So if this is a white ball, I cannot have a U shape because for U like this, I want to put my block here, but this one, I have to put it here, and this one, I have to put it here. So that doesn't work, right? So of course, if this is a black ball, then it works because a black ball, I'll put it here, right? So if I'm, so this is, if I go this way, okay? So if I go up, okay? If I go up, it's a similar situation, right? So I want to look at this situation. If I'm a white ball, I'm going to go this way, right? So this is my black, this is my black, this is my white. Black ball, I want to go that way. White ball, I want to go, sorry, black ball, I want to go that way. White ball, I want to go this way, right? So then, right, so that would be the case. I could make it work, right? So that is the situation. Sorry, because for this one is my black ball to the right. So my black ball is going, okay, right. My black ball is going clockwise, right, this way. Okay, so this one is going this way, right? So just because I'm going to the left and up. Okay. So those are the situations that I would not make it work. Otherwise, it could make it work. Right? Then I create a list of what it is. Then I can come out. So that's basically the answer. So now looks pretty straightforward, right? But you have to understand the black ball, white ball theory, or sometimes people call the red and the black theory. Here is an example code, which pretty much do what I was doing, coloring of the cells. Okay, checkerboard the coloring of the cells. You find the connectivity, adjacent matrix, checks the connectivity at a sign, right? It depends on your white or black, you assign it. Okay, then you build the tree. So this is a pretty straightforward problem. The complexity is obviously O of n, right? That's very obvious. As long as you know how the theory of deal with two color issues, then you would have no problem of solving this. If you don't know the theory, of course, it will be difficult. Frankly, this is one of the easier problems. The key problem and the block problem is one of the easier problems you will have. So try to implement today's homework is try to implement this by yourself, and then look at the next problem for next week. So the next problem is going to be then we still have 3 classes left for this year's class. We're going to talk about day 2 problems. Day 2 problem is a little bit more difficult. Please look at this week. Please try to solve the DNA problem. The DNA problem is basically how to, if you have 3 unique characters, how can you switch them to manipulate them by swap to each of the 2 characters? We know those are standard DP, as you know the standard. Those are DP problems, right? So, but this is a multi-dimensional DP. So you have to think about what are the tricks you can do to change the dimension, right? For each dimension, change from ON to O log n, right? Remember, there's going to have multiple dimensions. If you have 3 of them, you have 2 dimensions, right? Because if it's 1 or 2, then it has to be 3, right? So it's 2 dimensions instead of 3 dimensions. You cannot do n squared. You have to do n log n. So think about what other methods we can do to improve the complexity from ON to O log n for each dimension. Then we'll talk about the solutions next week. So thank you, everybody. We'll see you next week.